Okay, so children, we are going to take up now the chemical properties of phenol. So the properties are very interesting. Let's take one by one. तो phenol में हम क्या करेंगे? If we drop sodium metal in phenol, so what happens? Sodium metal is able to displace hydrogen, and the product will be sodium phenoxide, right? And you get hydrogen. Okay. Now, when we treat phenol with sodium hydroxide, now look here, phenol is slightly acidic, or you can say mild acid. It is also known as carbolic acid because of resonance. You know, this hydrogen or proton is donated, and this phenolate ion is stable because of resonance. So it is acidic in nature. When it combines with sodium hydroxide, it forms salt and water. So what will happen? You are going to get, see, this H and OH will form water, and you will get C6H5ONA plus water, right? Isn't it interesting? Next, when we take phenol and we treat this with zinc, so when this is dry distilled, right, when it is distilled with zinc, so zinc absorbs the oxygen which is present on phenol, and you get benzene, right, along with formation of zinc oxide. So this is an important reaction which can be used for conversions, right, conversion of phenol to benzene. Now next, when we want to prepare aniline from phenol, so what do? We take phenol and treat this with ammonia. Now ammonia अकेले react नहीं करता है. There is a condition, it requires zinc chloride. So ammonia can be written as HNH2. So what happens? OH from phenol and H from NH2 group is going to form what? Water. Very good. बहुत सही बताया आपने. And what do you get? You get benzene ring along with this NH2 group. So what is this? This is aniline. Again, this reaction is important, which is used for conversions. Okay. Next, we take up what happens when phenol is treated with PCl5, or it is treated with SOCl2, or it is treated with PCl3. Such case, always remember, the bond breaks along oxygen. Okay, so what will happen if I write like this? C6H5OH. So bond will break along oxygen. You're going to, if we take PCl5, then give Cl on right, Cl on left, and you get PCl3. So what is the product? C6H5Cl, right? POCl3 and HCl. C6H5Cl plus POCl3 plus HCl. Okay, now if you take SOCl2, then in that case Cl on left, Cl on right, and SO in between. In that case, instead of POCl3, you get SO2. Okay, so this reaction is same. I'll write this again. Okay, so this is very interesting reaction. So if it is C6H5OH plus SOCl2, you are going to get C6H5Cl plus SO2 plus HCl, right? And if you take PCl3, then in that case what happens? We take 3 parts of phenol. So 3 parts of C6H5OH plus PCl3. Now what will happen? These C6H5, 3 C6H5 and 3 Cl will form 3 molecules of C6H5Cl. Chlorobenzene. And what do you get? 3 oxygen, 3 hydrogen and 1 phosphorus. So H3PO3. Interesting? Okay. Next we take up what happens when phenol combines with acetyl chloride, right? So when it is treated with acetyl chloride, then what happens? This reaction, remember, takes place in the presence of pyridine. Okay, So I'm wrapping this so that we have a space and we can write reaction. Okay, so any guesses what will happen? Yes, H from here and Cl from here will form HCl, and you will have what? Right? This is O, right? C double bond O, CH3. So what is this? This is C6H5. So here it is CH3, COO, C6H5. Got it? Right? Next, when we take phenol with bromine water. So when we add bromine water, then in that case it forms white color precipitate. Now this reaction acts as a chemical test also for phenol. So what will happen when bromine water is treated with phenol? You get white precipitate of 2,4,6 tribromophenol. So this is phenol on second carbon, fourth carbon and sixth carbon. Bromine is substituted. Okay, so you'll get 2,4,6, right? This is tribromophenol, white color precipitate. And likewise, if you take aniline, aniline also gives the same product, right? But these tests are used for identification of phenol and aniline. Next, if we take concentrated sulfuric acid. So when we take concentrated sulfuric acid, in that case what happens? Now phenol is orthopara directing. Orthopara directing because it is electron rich group. Okay, so what will happen? There will be electron available, right, on ortho position, or it will be available on para position. So if we have taken concentrated sulfuric acid, then there will be two products. You will get ortho product and you will get a para product. So you'll get OH with SO3H, right, on ortho position, and SO3H on para position. So you get benzene sulfonic acid, hydroxy on second position or hydroxy on fourth position. Okay, next, if we take nitric acid concentrated. So if we take nitric acid concentrated, again phenol is orthopara directing. So what will happen? You will get again two products. Phenol is there, you will get on ortho position nitro group, or you will get nitro group on para position. Okay, now if we add concentrated sulfuric acid to this, then in that case what will happen? The reaction is going to further react and you are going to get the product. Right now in this case what will happen? You will have, this is say mono substitution, right? One nitro group is there. Now over here there will be a higher substitution. You will get 2,4,6 trinitrophenol. Okay, so let's see the reaction. Here OH, you will have NO2 on 2, NO2 on 4 and NO2 on 6. So this is 2,4,6 trinitrophenol, highly explosive in nature. So remember, if there is only concentrated nitric acid, you get ortho and para nitrophenol, and if there is concentrated sulfuric acid, then reaction goes further, there is further substitution and you get 2,4,6 trinitrophenol. Now we take up reimer-tiemann reaction, the important name reaction. Now in this reaction what is formed? Salicyl aldehyde is formed. Okay, so let's see the reaction. What happens? We can write chloroform as C, H, Cl, Cl and Cl. How many KOH? 3 KOH. So KOH, KOH, KOH. Now let's take what will happen. 3 chlorine and 3 potassium will form what? 3 KCl. Now you have got HC and you will have 3 OH. Okay, now since carbon is having more than one OH group, so this will become unstable and it is going to break. So you will have water here, right? And what will happen? You have OH here. So phenol is orthopara directing. So what will happen? Phenol is already here, right? And you are going to get over here CHO. Okay, so you'll get CHO here and you will get CHO on para position. Okay, so this ortho position is known as salicylaldehyde, right? So this hydroxy benzaldehyde is there. This is salicylaldehyde, which is important and used for preparing medicines, especially analgesic medicines or painkiller medicines. Okay, so next we talk about cold Schmidt. In cold Schmidt, this aldehyde is converted directly into acid. So the product is salicylic acid, right? Here what happens, phenol is treated with sodium hydroxide and carbon dioxide. Remember the temperature is 130 to 140 degrees centigrade. So what will happen, this COO, right, carbon dioxide will be, so here phenol is there and this will be converted into COOH, ortho and para. Okay, so we talk about ortho product salicylic acid, which is main component of aspirin, right? So and now next we take up the phenol dye reactions, or we can, you can say diazotization. So dye is formed and the name of reaction is coupling reaction, where we take with the help of benzene disonium chloride, phenol, combines to form bright, reddish orangish dye. Okay, so what will happen when we take benzene disonium chloride, treat this with phenol? So again, what is happening? Phenol is ortho para directing. So the hydrogen from para position of phenol combines with Cl and forms HCl, right? And the product is a couple. There are two benzene rings, so this is known as coupling reaction. So here N double bond N, okay, and this is OH, right? Now this is a dye, right? And this is also used as a chemical test for identifying phenol. Another important chemical test to identify phenol is neutral ferric chloride. So when phenol is formed with neutral ferric chloride or shaken well with neutral ferric chloride, there is always a change in color. Okay, then already we have done with bromine water also. Phenol gives white color precipitate. So phenol, these are the chemical properties of phenol, जिसको आप अच्छे से practice कर लीजिए, ये important reactions हैं, right? इनके conversions या identification और how will you distinguish between or how will you obtain type के questions आते हैं. Okay, so all the very best. Thank you.